Okay, next up we have Raúl Álvarez and Christoph Streit. They'll be talking about the creation of a circular economy-based cloud service. So over to you, Raúl and Christoph.
Yeah, thank you. Thank you very much.
Thank you
all. So maybe we should do a quick introduction and talk a little bit about who we are and what we do. So my name is Christoph. I'm the co-founder and CEO of ScaleUp. We are traditionally a hosting and co-location company based in Germany. We started 26 years ago, so a very long time ago, and have been involved in the whole open source community for quite some time and have been running open source infrastructure in our data centers. And well, came across OCP a couple of years ago and found it more than interesting. Started introducing OCP hardware platforms in our data centers, using them in our production facilities, and actually also became a OCP member last year and also part of the solution provider program at OCP, since we are selling OCP solutions to others. So to put our presentation a bit into context, I wanted to briefly talk a bit about the what's it called, the DACH region, so Germany, Austria, and Switzerland as a German-speaking region within Europe, which has its, well, how to say it nicely, a bit specific needs and things to consider when doing business. So first and foremost, there's lots of regulatory compliance and security standards that one has to follow, GDPR being the foremost maybe in regards to data privacy. But at the same time, at least Germany already has passed a law for energy efficiency. So data centers have strict numbers in regards to PUE and reporting of their efficiency, which they have to follow, and that is already a law which has been passed earlier this year, so it's there. There's no way around it anymore. And at the same time, since Germany is the largest economy within Europe, there's also the need to have local infrastructure, and because of the size of the market and the community, it's important to have local presence. So. Putting that into perspective, we believe that it's very important to be scalable and flexible to meet all those needs. So passing over to Raúl.
Absolutely. So one of the things that we're trying to achieve with building this circular economy-based cloud, well, first of all is, what's the point? What do we want to achieve with circularity? So we want to demonstrate actually that adopting OCP solutions coming from the hyperscale makes sense at a lower scale. And that has to do with how those machines are actually built and how all those data halls are actually built as well. So we say, and actually we have metrics. I actually encourage you to actually get a good look when all of that is actually released to our presentation with Ferg here and with Christoph yesterday, where we discussed about the specific metrics of efficiency with OCP deployments here. But other than that, if OCP deployments are actually efficient enough, I think that we can actually do even better enabling circularity solutions. And then actually, all of that is actually tied down with one of the things that we have discussed before, which is actually the need of being efficient and being sustainable in the DACH region. So this is actually a region which is actually very heavily regulated in terms of carbon footprint and sustainability. So we are actually aiming to be compliant with all of the regulatory compliance, let's say, legislation there. And then, I mean, we want to be different. We want to differentiate ourselves in the market, and we want to be on the forefront of technology. So even if it's kind of, we are using reused equipment, so we are actually not using the latest of the latest. This is actually a very good way to differentiate ourselves in the market. And that goes with innovation and with a cost reduction, because we are acquiring those equipment, that equipment from which is actually not the latest of the latest, so the market is not charging us that much. And I want to discuss about the supply challenge, and that goes very well with my last point, because yes, those machines, if you think about it, they should be, I don't know, they should be cheaper, right? We are actually using second-hand equipment. That's a very, very bad word, but it comes with challenges. The challenge is mostly that, I mean, and I think this is actually a good anecdote that you did yesterday. I mean, somebody approached you at some point, so hey, Christoph, do you want to buy some Facebook servers, right? But those machines, as part of the repurposed process from Facebook, they usually don't come with a specific hardware. They don't come prepared, ready to use. So there's some need to actually to create an ecosystem and to be an ecosystem available to create that ecosystem to support the repurpose of those machines, so they are actually fit for purpose on a standard data center to be offered to our customers. So we are talking about firmware and actually working with our colleagues there at 9 Elements. So those machines are actually end of life, and we need to actually have them up to spec in terms of firmware, security, and complement with storage and networking. So it's not only about the machines, it's about the whole rack in that sense. And you cannot do that alone. That's the point. So we are working with all of those companies to enable those solutions. And there's some challenges along the way. So we have the knowledge about the workloads that we want to run. And we're working with them to procure every part of the solution. But the overall picture and the overall knowledge about the solution, this is something that we handle very well. So yeah, IT/AD companies, they only have the hardware perspective. And we know very well the workloads and how to design for scalability. And then there's actually another very interesting challenge, which is actually very interesting to discuss right now, which is actually how we enable circular AI and ML in our data centers. Because you may understand that this kind of workloads require the latest of the latest equipment, but this is not usually the case. We made the case to actually offer to the market repurposed equipment, which is actually not the latest equipment, and those machines are actually still fit for purpose, and we can still offer these kind of machines that are actually not running H800, NVIDIA Blackwell, but other set of GPUs that are still interesting for the market to consume, and we are actually extending that lifetime. Why all of that works? And actually, I want to refer here to Eric and to Flux Computing. This is not new at all. This is something that there's research already being done about how we can actually extend the lifetime of those machines, and that's precisely the case. We want to actually extend the design lifetime of those machines. So the sustainability goes and works because we are actually still using those machines that are still fit for purpose. And that's actually the point. So we are not deploying the latest of the latest. All of the non-intensive workloads, so think about web hosting, think about light applications, they are still fit for purpose to run on this kind of equipment. And there's actually a huge stock of ORB2 racks available in the market that we can actually procure and we can repurpose. So we are still extending the lifetime of that set of machines. And this is just an example. And you can actually see here the Sesame logo, which is actually one of the pioneer companies that actually enabled this ecosystem to happen. This is just an example. And let me discuss how we integrate this vision with our current portfolio. So I don't know if you want to discuss about the portfolio.
Well, not in detail, but to give you a quick overview. So the idea is, since we kind of tend to use this equipment ourselves, we figured that we might as well help others in the German market or in the DACH region or even in all of Europe to do the same. And so we have different approaches on how to do that. So we can offer like a full set of compute, storage, network, whatever, hosted in one of our data centers, or we will help a customer actually procure all this equipment, the circular equipment, maybe some new equipment as well, integrate it, and then actually put it into production on premise at the customer site. So there's multiple ways on how we can do it. The idea being that it just makes sense to go down the road and use OCP for that, and especially circular hardware in detail. So coming to the conclusion, we believe that circularity is feasible. There's still a few things that need to be done in order to establish this supply chain, and especially there needs to be some more effort on the whole topic of firmware for servers, because it's just impossible to put a circular server into production at a company who has tight security regulations when you don't have any BIOS updates, firmware updates in place to fix any open vulnerabilities. So the idea to go down the path to use open firmware is actually what we would like to encourage and like to do, but I believe there's still some room for improvement around that.
Yeah.
So the other challenge is measuring and reporting Scope 3 emissions, and that's, well, potentially a complete different topic, and I have another presentation this afternoon talking a bit about that, since we're involved in a government-funded project in Germany where we are trying to figure all these things out and actually enable a solution where someone who wants to run an application can put it into essentially a software stack that we're going to create. Then this application is tested and verified on that software stack, and then that software stack will potentially tell you how large the CO2 footprint of that single application is when you run it on a cloud environment. And to do that, we don't only need to measure Scope 2 emissions, like the power usage of the servers, but we also need to get much more detail on the embodied carbon in all of the servers and all of the infrastructure. And that's already difficult to do with established hardware vendors. In the OCP world, it's also not that easy, but I think there's some interesting projects within OCP to get more data, and I do hope that OCP in the end will actually make it easier for us to get all that information in order to come up with better numbers to actually report on Scope 3 as well. So yeah, we are working on it, and I guess with that we can open up to discussion, because I'm guessing there's a few questions around that.
Please.
We have a microphone, please.
Oh, right away. That's great.
Hi, Lauren Long.
Hi, Lauren.
So, because you're green, are you allowed to charge a premium, or because you're using used hardware, people expect a discount? So on the commercial side, I'm curious on the
So
your
we actually,
experience.
we actually openly talk about using refurbished. We don't charge a premium for it, no. But then we also don't offer any large discounts because we believe it's the right way to try to improve, right? Make it better. And the message we get from customers and potential customers is that this is what they're looking for. They want to have something like it. I mean, that's one of the first questions when there's a new customer coming, either for the data center, for the hardware, whatever. They ask you about all those details. Can you tell me how green you are, right? That's the first question nowadays. Let's see.
I was wondering how you, what your experience has been with warranty claims and how you handle that, and do you have a full supply chain backing all the way into the core manufacturer that you may need if you have to troubleshoot an issue?
Well, we try to handle that ourselves. But we already did that with the established vendors before. I mean, we figured that, we worked with HP and Dells of the world for a long time. And even back then, we at some point stopped trusting their warranty services and just handled it ourselves.
Right, so you have diagnostic capability down to the memory cell of an NAND flash?
No, we don't.
Okay.
We don't have that. We
All right.
then discard it or give it back to the vendor at some point, and we just replace it ourselves with a new one. We have stock, and we just replace it.
Got it, okay, and that's important. So the customer is not experiencing you to
No,
provide
no.
that service, right? Worst case, they're going to get a replacement.
Yes, they get a replacement.
Okay.
They shouldn't worry, and that's the main discussion with many customers. They
Yeah.
don't want that hassle, and they shouldn't really.
Okay, thank you.
That's a service. Yeah.
So
Any other questions? Okay, thank you.
Thank you.
Raúl and
Thank you, Priya.
Christoph.
Thanks.
And thank you all.
Sistem güzel.
Okay, so next up we have Kagade and Ender presenting on energy-aware workload orchestration on OCP servers using Kubernetes.
Doesn't matter, I can handle from here. What to do?
Okay, over to you.
So welcome everyone. today we are going to talk about the progress of the European Commission-funded EcoCube project. My name is Çağatay Yılmaz. I'm working at Rice Research Institutes of Sweden, and I work pretty much about sustainable digitalization. And my colleague Ender is here. You can introduce yourself.
I'm Ender Demirel. I'm the founder of DS Tech Design and Simulation Technologies. So at DS Tech, we are focusing on the CFD simulations of thermal simulations of air and liquid cooled IT equipment, as well as thermal simulations of data centers.
Thank you, Ender. So yes, we will start talking about cooling. I know that it conflicts with the title a bit, but we know that actually cooling and the performance and efficiency of the IT devices, they are totally correlated. So the other day, I was reading an article, and it was about the last ice age. And there was a significant detail about this. I heard that in an average, in the last ice age, the temperatures were only 47 degrees Celsius lower than today's average temperatures. So I was thinking, hey, it shouldn't be right? Like only 4 degrees. Then I remembered, okay, most of the data center owners, just to be on the safe side, they are actually lowering their cold aisle set points. And basically, this is, again, from my experience, something around 4 degrees. So 4 degrees is a significant amount. So are we overcooling? Or in the big picture, if we see the big picture, if we can actually modify in a controlled way, control the cold aisle temperatures, can we actually achieve better efficiency for the data centers in the future? So yeah, the main question is, are we overcooling, and how we are improving the efficiency of our data centers? So for us, there are two kinds of cooling. One of them is the traditional cooling, where we cool down the environment. In the most efficient case, like we list in the presentations, there are cold aisle containments or hot aisle containments. We are trying to not to separate hot and cold air, and we are trying to improve the overall efficiency. That works fine. It worked for years so far, and we are happy with this. But we are trying to introduce a paradigm shift to the market with the EcoCube project, where we focus on the compute element. The main question is, if we listen to the data center a bit better, if we really listen, pay attention on how it's performing, can we turn this system into something better? So the traditional system, you all know this schematic from Esri. This is a great tool. I love it, and we still rely on this tool. So in this system, what we do, as discussed, we cool down the environment. So the Esri standards shows us, and the IT systems manufacturers, they say, okay, you have to cool our devices within the recommended envelope, or A1, A2, so we just follow the instructions. Because we know that if we do so, we both guarantee the performance of the IT devices, and we also guarantee the overall efficiency. However, what we are trying to do in the EcoCube project, we try to listen the IT devices itself. Yes, this schematic is from a Raspberry Pi. This is not a traditional IT system that you are working with. But the main idea is the same. So I deliberately put this picture because there are no fans. There is nothing that can disturb us. And we can clearly see the thermal effect. And the thermal throttling on the IT devices. So what we said, we want to maintain the performance, but meanwhile, we are trying to optimize the efficiency. So on the second picture, we discussed a lot how we can do this, how we can achieve this, maximize the performance and efficiency. So in this system, we go back to the environment cooling, and we have our standards. And in these standards, what we do, I'm talking about the air cooling systems right now. we make sure that cold air is flowing through the server, cooling the server. So how we listen all the servers all together and make sure they are sufficiently cooled. This is a bit tricky because it looks like, hey, you are taking a shower and you have a desired temperature, and this desired temperature, you also have a desired water flow. And you have two knobs, a cold knob and a hot knob. So how you optimize the angles of these two knobs and make sure that you get the right flow and the right temperature. And meanwhile doing that, if you consider that there are hundreds of servers in a data center, in the big picture, how you make sure that all individual server is receiving the right amount of the coolant for the optimum operations. This is the engineering problem that we were facing. Okay, this is the background history. Now my colleague Ender is going to deep dive into engineering side. Ender, floor is up, yours. Couldn't get it, yeah.
Okay, thank you. In order to minimize IT and cooling energy consumption in data centers, we developed some tools such as EcoServer Power, EcoFTE, EcoEO, and EcoDynaCool in the scope of EcoCube project. EcoServer Power is developed for the prediction of the power consumption of OCP servers, which is very important for the optimization of workloads inside the data center. The thermal prediction or thermal side is an important parameter because there is a strong interaction between temperature distribution and power consumption of servers. So the fast estimation of the CPU temperatures and outlet temperatures in a data center, we developed EcoFTE tool. EcoEO utilizes EcoServer Power and EcoFTE for the minimization of IT energy consumption to optimize the workload distribution inside the data center. And finally, EcoDynaCool optimizes the cooling parameters such as fan speed and valve opening ratio, which is very important in EMPA data center, which is one of the pilot sites in EcoCube project. So I will give a brief information about these tools. EcoServer Power has been developed for the Leopard version 2 OCP server, which was deployed in EMPA data center in Switzerland. So the power consumption of the server consists of the IT power consumption and the fan power consumption. So the IT power consumption can be classified as the idle CPU dynamic pressure, power consumption and the leakage power consumption, which is connected with the CPU temperatures. In order to understand the IT power consumption inside the data center, we carried out experimental studies using different server utilization ratios and fan speeds. So, and we have seen that the hyperthreading is a very significant parameter for the power consumption of the server because a sudden drop has been observed when the utilization rate exceeds 0.5. So based on the experimental studies, we proposed an empirical equation and a partial empirical equation, which is valid below 0.5 and which is greater than 0.5. So this equation can be used reliably for the estimation of the power consumption for a given workload and fan speed in this system. So we conducted additional experimental studies in order to test the accuracy of this equation, and we have seen that this equation can be used reliably for the optimization of the workloads. So in EMPA data center, 24 OCP servers are deployed. So in order to estimate the CPU temperatures, CPU temperature is a very important parameter for our algorithms because we optimize the workloads depending on the CPU temperatures, looking at the CPU temperatures, keeping them below the threshold values instead of inlet temperatures. So we performed a series of numerical simulations for the estimation of the thermal side. Then we created some matrices and for a given workload and cooling environment, So this EcoFTE algorithm can predict the CPU temperatures below 1 second for a given workload and cooling environment. So we assess the performance of this algorithm using experimental studies. Experimental studies were conducted in EMPA data center. So the predicted and collected values were compared. As we can see in the figure, the FTE algorithm can predict CPU temperatures accurately with the IPMI data. The EcoEAVA tool uses EcoFTE and EcoServer power for the optimization of the workloads for a given workload inside the data center. So we performed numerical and experimental studies for the demonstration of the impact of these tools in the relevant environment. During the numerical studies, different kinds of optimization algorithms were used, such as the randomly distributed population algorithm, particle swarm optimization, and genetic algorithm. And we have seen that the randomly distributed population algorithm is superior to other numerical methods. So we selected this algorithm during the experimental studies. We conducted experimental studies using some dummy loads created by OpenFOAM using Slurm job submission algorithm. And we conducted 4 experimental tests, and we compared the results of EcoEAVA with the conventional workload distribution algorithm. And we have seen that the IT energy consumption can be reduced by up to 15% when EcoEAVA tool is used for the optimization of the workloads inside the data center. So here is the architecture of EcoEAVA. As Çağatay mentioned, we have to listen to the data center, so there is a strong interaction between our tools and Prometheus to collect the thermal data from the system. Then, when a new task is submitted to the data center, EcoEAVA distributes the workloads in a way to reduce the power consumption inside the data center. Then, as we mentioned later, the Kubernetes system can automatize this system in the near future. The second tool is the EcoDynaCool, which focuses on the minimization of cooling power consumption in a data center. This is the schematic figure of cooling system in EMPA data center. We have to minimize the power consumption of the cooling system by optimizing the fan speed of the cooling system and valve opening ratio, which adjusts the flow rate passing through the heat exchanger because heat is removed from air using this heat exchanger. So we need to reduce the heat load sent to the chiller, which is located outside of the building. So the cooling parameters, the optimization parameters are valve opening ratio and inverter fan speed. So our constraint is the CPU temperature should be kept below 80 degrees Celsius, which is available for this type of server model. Our objective function is the power consumption of the total power consumption of the cooling system. We developed an optimization algorithm in here. So depending on these constraints, the cooling system's parameters are optimized. We compared the default and the current cooling system's behavior with the developed algorithm, EcoDynaCool. The EcoDynaCool can optimize the cooling parameters in a smooth way in comparison to the default algorithm, because the default algorithm can open and close the valves of the cooling system in order to set desired supply temperatures. Our algorithm can predict the CPU temperatures in an accurate way, so the cooling parameters can be optimized depending on these values. Then we compared the power consumption of the cooling system with the conventional, with the current cooling system in EMPA data center, and we have seen that the EcoDynaCool can reduce cooling power consumption by up to 35% in comparison to conventional or current cooling system. As Çağatay mentioned in the beginning of the presentation, instead of focusing on the inlet temperatures inside the data center, our chip temperature-based algorithm can keep the CPU temperatures below the threshold value. So by increasing the inlet temperatures about 28 or 29 degrees Celsius, these energy savings can be gained. So this is a very critical parameter. So we monitored the CPU temperatures during experimental studies, and because of the accuracy of the numerical model and experimental studies, the CPU temperatures were observed about 78 or 79 degrees Celsius, which is so close to the threshold value. Okay, this is your side.
Yes, I wish our DevOps engineer Oğuzhan was here today, but he couldn't make it. Visa issues. What I can say, like the challenging part, all we discussed here, it's a research project funded by European Commission. So the next question is how we are actually carrying this dedicated important work into real life environments. So one of the biggest obstacles in front of us is still relying on open source technologies and make it globally available. So obviously we use Kubernetes as our main medium, and we have chosen, instead of developing like really heavy middleware applications, we decided to train Kubernetes. So our Kubernetes, instead of standard Kubernetes scheduler, it is not only allocating the loads randomly as it does, all the tools that we already discussed, they are step-by-step being integrated into the new Kubernetes scheduler. So what the system does, there is a continuous loop. So whenever there is a change on the IT load, the system asks the IT device itself, all the IT devices itself, hey, what is the current status? And cooling, hey, what is your current status? And basically, altogether, this system smartly allocates the workloads, plus controls the coolant side as a promise of a holistic coolant system in the data centers, which optimizes both hardware and software elements of the data centers. So the whole presentation that we discussed today is actually just focusing on the data center side. But what EU is trying to do on the way to climate neutrality, this is a grid integration problem. This is a problem that we need to optimize. Yes, the data center itself, then to integrate it into the grids and energy systems in the most efficient way. So unfortunately, we don't have time to cover all the project scopes and goals, but what we are doing is going to be compatible with the new EU regulations, and we're going to be discussing about it during the next presentation. So I would kindly remind you to stay with us to hear more about the new EU regulations, especially the Energy Efficiency Directive. So main takeaways of this presentation, yes, listening data centers and IT elements like compute elements makes a difference. And if you listen it well, the minimum energy gains is around 15% on the IT side. However, if you combine this IT efficiency, and if you have a holistic methodology and combine it with the hardware of the system components, especially the cooling, you can your systems can, instead of cooling the environment, they can understand the cooling requirements of the IT equipment and optimize the cooling efficiency as well. And our systems, as Ender just mentioned, smartly increased the inlet temperatures in our initial studies around 4%, and this 4% was equal to 35% in efficiency gains on the coolant side. What I'm trying to say, this is a great potential, and such research has to be continued to take these technologies and adapt them into real-life data center environments. And our call to action, yes, follow-up EcoCube project. We are in the last 6 months of the project, so from now on you will hear more about our findings. Follow EU Code of Conduct data centers, where you can find the latest trends and information about the data centers efficiency. And as discussed, join our next session, where we will discuss the overall feature of the data centers energy efficiency. So thank you for coming.
Thank you, Chage and Ender. Great presentation. Any questions?
Oh.
I used to work with them as well. Great to see some results. Okay, so the first question will be like, what you see is with EcoDynacle that if you raise the inlet temperature, that the power consumption goes down. Have you tried to increase that inlet temperature as well and see what's the difference then? Like if you have now you also had a difference in inlet temperature, but what if you forced the system to have that higher inlet temperature? What's the reduction that you get then?
Okay, I will leave it to you, but I think our system boundaries here was the CPU temperatures, because we don't want to burn them. So continuously tracking, actually, you know it, but continuously tracking the CPU temperature let us safely increase the CPU temperatures. Meanwhile, the smart workload allocation in the data center is making us sure that there is no hotspots in the data center. So it's like try to avoid hotspots before they happen, right? This was the main motivation when we started the project. Do you want to add something?
Our first constraint was the CPU temperature, so we tried to keep this value close to the threshold value. So when we observe the inlet temperatures, we have just noticed that the inlet temperatures has increased the standard values or suggested values by ASHRAE standard, for example. This increasing has provided a gain in energy saving in EcoCube project.
Can you go back to the utilization of the power slide, please?
EcoServer power, maybe.
EcoServer power.
Yeah.
Was it on the?
Further back.
It should be back, yeah. Yeah. One more slide.
One more? This one?
Yeah.
That one, yeah. Does this take into account the change in behavior and relationship between server power and server utilization when you modify the BIOS from power efficiency mode to performance mode?
No, because we didn't want to modify anything, especially on the BIOS.
Which is this in then?
Pardon me?
Which BIOS setting is this in?
I wish Oğuzhan was here. I need to get it with an email because, visa issues.
Oğuzhan was provided this service to us for the controlling of fan speeds and utilization rates. So he knows the details. He's not here, unfortunately.
And just a quick second one. On the next slide, the power model that you've got there only incorporates CPU and temperature. So I assume your workload is a CPU-heavy workload. Is there any plans to incorporate memory stressing workloads or storage stressing workloads into your power model?
It's a great question. This is one of our limitations because so far in this research project, we have to focus on the CPU-intensive workloads, not memory or not the GPU-intensive workloads are not studied in this particular study. But this is one of the limitations and we have to work on it in the future.
We should talk after this.
Yeah, sure.
Okay. Thank you.
To ask a question then, yeah.
And I'm scared
Yeah.
now.
Okay, so getting things straight. So you're not altering the fan speed. You're letting the BIOS change the fan speed.
Yes.
Because if you remember the Bowden type project that we ran at RISE, we took control of the fans. So the issue here is obviously when you're running at 80 degrees centigrade, your fans have slowed down quite a lot. So you're trading current leakage or wasted energy through the CPU, if you like, heat generation, with the fan energy dropping. That's how I understand it first, but that's a statement first. But the question I have really is on the 35%, does that take into consideration the cooling outside of the rack? and are you just focusing on the reduction in energy consumption in just the cooling infrastructure, the fans and the downstream cooling in the rack?
Yeah, brilliant question, but the answer relies on what EU wanted us to do in this project call. So it was a like data center integration into a building. So what we considered about the cooling power consumption is our load that we send to the chillers. So we didn't actually consider like basically the whole cooling system's efficiency, because we are a small piece of the puzzle in the equation. So
this is the rack
our
level.
boundaries are just in between this micro data center.
Okay, yeah. Because really, the optimal thing about efficiency really is the workload that you're doing for the energy you're consuming. So, and I can go on about this, but maybe we'll talk about this in the next session. Yeah.
Thanks, John.
Maybe I can welcome you to the stage too.
Well, thank you all. Thanks, Jacques, and
Thank you.
good presentation.
You guys have another person that's going to come up for the next presentation?
Yeah, I'm here, and John Summers and Mark will be joining us.
You're all connected?
Yeah, I'm.
Let's get everybody settled in.
John,
Switch with you.
I have to borrow this.
So I need to put this on.
As you wish, but I'm still here. Discussion, please use the mic. It's better to use the. Okay. I'm sorry.
Are you guys okay to use the mic?
Yeah, we can use the hand.
Okay.
Or we can shout.
All right, we're going to get started. We're going to welcome Kagate.
Yes, Chaatai, but no worries.
How do you say?
Chaatai, yeah. It is
Chaataya.
challenging.
All right. Chataya, John and Mark.
Yes. So I'm not going to introduce myself again. This is another presentation that we want to discuss. Actually, let it be a non-formal brainstorming about like what is happening with these EU regulations and how to see the big picture, like how they are going to affect our market. So I promise I'm not going to speak that much this time, and I have two British accents here, John and Mark. Mark, we can start with you. Can you introduce yourself?
Yeah, my name. Oh, okay, sure. Yeah, good morning. My name's Mark Acton. I'm here representing a company called EchoSense. I've actually been involved in some of the stakeholder discussions with the European Commission, both for CSRD and EED. So hopefully I can provide a little bit of insight about what they're trying to do and where they're going. Happy to answer questions on that, make it interactive, but I think, Chataya, just bring me in and sort of quiz me as it goes along. Yeah, thank you.
And John?
So it's John Summers. I am a colleague of Shatai, so I'm scientific lead in data centers. So we let the data do the talking. We throw the opinion out of the window, and it's all about the data. So and they want to collect data, don't they? The Energy Efficiency Directive. I'm not sure what they're going to do with it, but maybe we'll find out from Mark. Yeah.
I'm not sure they do.
So no, I will be here. I think this works as well. Okay, great. Mark, we are all confused. Can you just let us know what's happening? What happened really? What kind of regulations that we are facing?
Okay, well, there's two distinct sets of regulations that have come in that we are now, within Europe, we need to address. First one is CSRD, Corporate Sustainability Reporting Directive. That is actually largely based on the EU Code of Conduct that Chaté had up in his last presentation. That's a set of 160 plus best practices, which if you initiate them, will save you money in your data center operations in various different ways. That was converted into an assessment framework. It was referenced in the EU taxonomy, and it tells us what we should be doing in reference to CSRD. Are the Commission going to police CSRD? No, they're not. What they're going to do is they're going to ask sustainable funds to not provide sustainable funding unless people have completed a CSRD reporting, completed their CSRD reporting. They are therefore effectively leaving it up to the investment community to police this for them. And the stick, if you like, or the carrot, whichever way you look at it, is the fact that you will or will not get access to cheap money. So that's what's happening. That's already in effect. We need to do the reporting. The reporting is largely standards-based, based on the ISO 30134 series. And if you haven't heard of it, you should have done, and make sure you look it up and use it. The second thing, EED, is actually run by a separate DG within the Commission. So are they connected together? No, they're not. Are they contradictory? No, they're not. They are supporting, but they are completely separate initiatives. EED, Energy Efficiency Directive, the reporting period has already started. So your reporting is due September this year. Hopefully that sends a bit of an alarm bell to those who haven't heard of it. Exactly. So what have you got to report on? Again, what they're doing largely, not explicitly, but largely, they're basing the reporting on the metrics which are defined in the ISO 30134 series. That includes PUE, WUE, ERF, so energy reuse factor, renewable energy factor, REF, so how much of your energy is actually being, excuse me, sourced from renewable sources. So there are these metrics out there which we're using. And one of the really interesting ones, and probably the most challenging one, is the fact that for co-location operators, they're requiring the co-location operators reference a KPI called ITEU, which is the IT utilization factor. This is for colos. To bear in mind, the colos have no real responsibility over what's going on the IT side. So it's going to be interesting. The Commission, I think, are on a journey. And have I got enough time? Am I taking too long?
You go on.
Sorry, I get a bit passionate about this one. The Commission, I think, are on a journey. They are well aware that what they've asked us to do is a little bit woolly. They are telling us that they're going to ask us to report on a standards basis, i.e. a level playing field. We're not going to be able to game PUE or WUE because it's going to be required that we report against standards. Interesting, actually, ED, they're not requiring PUE, they're actually requiring the numbers, your incoming, basically, utility billing number, your incoming KWH, kilowatt hours, versus what you actually supply to the IT side. So, they're kind of almost trying to avoid you gaming the number because they're going to try and go back as far as possible to the core data. Back to John's point, use the data, right? Are they going to be penalising us this year or next year? Probably not. Probably not. They're on a journey. This is very much the thin end of the wedge. What they're doing is they're collecting data. They will then adjust the regulation, the EED regulation, according to the data they see. This is my final piece on this. There was a direct quote from one of the policy officers involved in this, a lady called Laura Balker. She said it took us 15 years to regulate the glassblowing industry. And you're all going, what on earth has that got to do with data centers? And she said exactly the same thing. I know, I get it, I know you don't understand what I'm talking about, but she said, it's an energy-intensive industry. We don't know who's doing it. We don't know where they're doing it. And we don't know how much energy they're consuming to do it. So she said it took us 15 years to regulate that industry. I'll leave the rest up to you. John?
Well, it is about the data, isn't it? And I guess a data center is already in a good position to collect the data. But to your point about the PUE, I mean, I get annoyed about these things. They're not really sustainability metrics, are they? Because they only capture one aspect of sustainability. I mean, we can talk a lot about that. I mean, obviously, the use of water but it depends where you are, whether you're in a water stress area or not a water stress area. It depends on the impact, the environmental impact of that. Well, let's go to the PUE you like talking about. PUE, you love it. Yeah. The problem is, yeah, so if they're going to take, where do you measure the IT power draw? Because if you want to game this, you give the Commission the actual IT power at the furthest away from the IT. because then you're not giving them all of the losses in your system. So you have no idea what systems you've got, what power distribution you've got from that. So you measure it at the UPS, and then they can look at the PUE. Yeah.
If I can interject, and the best way to make your PUE look really good is go and hire a load bank from Rent-A-Load and stick it on the back of the UPS. You'll consume a lot more kilowatt hours and it costs you a fortune, but your PUE will be great.
So the question is what do they want the PUE for? I mean, we know that we've mandated some geographical locations against PUE. I guess that's against design PUE, isn't it? Before you actually build out the, and then design PUE is never the PUE you actually get when you're in operation. You know, there's a lot of other factors to consider in this. But again, you know, the heat recovery, the energy reuse factor, you know, that's the amount of the energy that is. And there are, if you look at the isometrics that you mentioned, I mean, whenever we talk about PUE, we should put ISO in front of it to say that we followed the ISO.
ISO 3014-2. That defines PUE. Anything else is not.
But the energy reuse factor is a bit of a tricky one. So I think, you know, I mean, we talked about this. I mean, we probably will talk about this at the heat reuse panel discussion today. I don't know whether Jaime is in the room, but it's a big topic in Europe to reuse the heat from data centers. But of course, if you start mandating against PUE, and you are an owner-operator and you have heat pumps to upgrade the heat, to get the heat across your boundary, then your PUE is basically screwed a little bit because you've got a mechanical cooling in the loop. But then the other factor of that is if you're giving the heat to a heat network and they're upgrading the heat for their heat network, for example, they provide you cooling back. And we had a discussion about this. The PUE says that if you're getting cooling across the boundary, if it's coming from a facility provider, you have to factor that in your PUE calculation. But I don't think anybody's done that. And you've looked at this as well. And so it's not a level playing field when you start. And so these metrics really are part of rubbish, really, at the end of the day. Well, it's supposed to drive internally what you're supposed to be doing, isn't it?
I mean, they're not perfect, John. I will concede that. They're not perfect. But I think it gives us a direction of travel. And I think it hopefully produces a somewhat more level playing field than we've had in the past. At least we can reference those standards and we can audit against them. So, you know, the idea is that it does away with a certain degree of greenwashing, etc. So, yes, they're not perfect, but I think they're better than nothing.
But actually also we are here today because during one of my meetings, I received a fantastic question. The question was, yes, now there is energy efficiency directive and there is the sustainability indicators. So are we climate neutral now? And I was like, no, we are not even close. So why we are tracking that? So let me go to the next slide. So I'm a bit confused. What's happening? Like, yes, this is a system level approach, and that's really great that we have some insights about how we are doing. So I accept it. And I'm really happy that we are not only building our data center on one PUE KPI. So I'm happy, I'm amused, but what's happening, like, so if we consider like our environmental performance into different scopes, so basically in this equation, John, my first question is to you. We have a lot of dependencies, and especially we have a lot of dependencies on the grid. So in this schematic, like with these KPIs, how would you compare the performance of a data center in a really environmental friendly grid and with a non-environmental friendly grid? Like, or efficiency, the KPIs, does it matter in this case?
That's a really hard question too. I mean, move all your data centers to a zone where you've got low carbon impact electricity. Yeah, I mean, perhaps we should be doing batch computing. Yeah, I mean, if it's not transactional, well, you don't need the latency. You don't have to deal with the latency. You put transactional, non-transactional workloads in a low carbon grid, low carbon intensity grid. But I think, you know, we need to have a level playing field here with that, you know, depending on how you generate your electricity, you know. And the grids are, I think it's well defined now, isn't it, that the carbon intensity of the grid. I mean, maybe it's, So when you're using, for example, wind, you're using the environment, which is basically it's the sun at the end of the day, so solar, wind, or whatever, to generate electricity. It's not emitting carbon, yes, but there is an embedded carbon, and that has to be factored into the energy generation. So you can't say it's zero carbon. I mean, climate neutrality or carbon neutral is a bit of a difficult one. And then, of course, the IPCC, it's the Paris Agreement, the COP20, I can't remember which one it was, 2015, they said, oh, we can't really do this like this. We have to talk about something else, which is called net zero. But net zero is not zero. It's about, you've got to, you emit carbon, the whole infrastructure is carbon intense. We know that. Everything we do emits carbon. Or it has a carbon intensity. So it's about offsetting that. And of course, that we're in this debacle now of and I think it's greenwashing, to be honest. I mean, we're all trying to offset, but even when you take airlines, the first thing, when you get to the end of your booking, do you want to offset your carbon? I mean, where does that money go and what does it do? Is it really the right way to go? I mean, Bhutan is actually carbon neutral. The reason is that they actually are biologically sequestering the carbon that they emit. It's a small country. It's sitting on a huge amount of minerals, but they haven't mined those minerals. It won't be long before China or somebody else gets in there and starts mining it. But the thing is that the carbon that they emit is absorbed by biological sequestration. We have to maybe sequester, and this geologically sequester, which means capturing the carbon out of the atmosphere somehow and putting it back in the ground. We don't want it in the ocean. We don't want it in the atmosphere. We want it back in the ground. That's the idea here. And 2021, globally, we sequestered 40 megatons of carbon, but we emitted 40 gigatons. So we got a long way to go. But this industry is this is not the savior. I mean, there are other intensive industries that are carbon intensive that really need to be focused on. It's just that this industry seems to be getting a lot of attention because of the hype around it and maybe all the activities that we've got going.
In this case, Mark, do you think EED or next level, next versions of the regulations, are they going to focus? I acknowledge they took a great step, but are they going to acknowledge or drive to a wider spectrum of the efficiency, or what we should expect next?
Absolutely. No, we know they are. As I said earlier, they're collecting data. The EED is a first step. Possibly part of a 15-year program, and EEDs are the Energy Efficiency Directive. It's not the Sustainability Directive. So it is a core focus. And I think also, when we talk about sustainability, I think it's very easy to forget that, we've got scope 2 and scope 3. The scope 2 is the use phase. The scope 3, as John suggested, is the embodied phase. It's what's actually embodied in products when they're either extracted from the ground or created. We're not even doing scope 2 very well at the moment. Let's get scope 2 right before we spend too much time killing ourselves over scope 3. Scope 3 is all about the supply chain. How much of that information is really, truly available and how accurate is it really? How many different ways are there of calculating your embodied carbon, your scope 3? So I think the onus is on us as an industry to manage our scope 2, manage our operational phase as far as possible, and hope or pressure our supply chain to give us more accurate information on scope 3 so we can push back on that and make sure that we are reducing the amount of embodied carbon. And that's the only way we're going to get to true sustainability.
But in this case, Mark, I have a counter question to you. We know that the current studies show that the edge computing investments, they are in megawatt scales right now, like in aggregation hubs, closer to populations. So in this phase, they are in scope of EED, and we also know that cooling is one of the greatest power consumption items in data centers. So is this system, is it fair for data centers? Yeah, we publicly disclose this data, but what about a data center in Lille versus a data center in Turkey? How we will compare them? Is it a fair comparison?
Well, there's a reason that there's a lot more data center activity in the UK right now. Let me put it like that. Maybe and I'm not a Brexiteer, let me stress this, but maybe one of the very few silver linings in Brexit is that we're no longer being covered by CSRD and ED. So slightly controversial comment, I accept, but I think it's interesting what you saw about edge. What's edge? How do we really define edge? Edge is, I think, a bit of a marketing term, isn't it? But if you consider that EED is currently only looking at data centers greater than 500 kilowatts IT load, then, are people going to shift their loads into edge data centers that are 450 kilowatts and go below the radar and hide? Possibly. It may happen. I don't know. But actually, the Commission are aware of this. So actually, the original threshold was 100 kilowatts of IT load. They only moved it up to 500 kilowatts because they realized they'd be deluged with data they couldn't handle, frankly, and nobody's going to report it anyway. But in 3 years, they are talking about dropping it down to 200 kilowatts. So again, we're on this journey. How will it affect edge? I don't know. I mean, I'm being slightly controversial. It might drive people to the edge. It might actually encourage the use of lots and lots of small, inefficient data centers. Who knows? You know what it's like when you introduce regulation. There are always going to be some unintended consequences, and I think they're figuring it out. And one of the reasons that it is so woolly at the moment is they didn't want to break the industry. They didn't want to penalise us. They realised that as an industry, we're desperately important to economies, not just in Europe, but clearly around the globe. So they didn't want to break it, but they are nudging us in a direction. There's no question.
John, in this...
We may want to open it up here.
Yeah, sure.
I think we've identified the rock stars of data center sustainability. We've packed the house here. So I think we may want to open it up for questions from the audience with the last few minutes.
You mentioned one of the metrics included IT utilization efficiency. Yes. Could you speak a little bit more about what underpins that?
Well, I don't really. I'm not an IT guy. I put my hand up and say I'm sort of more of a building guy. It's measuring what it's intended to do, and I can't give you the true calculation because, again, it's not really my sort of area of expertise. But what it's trying to do is overcome the situation where we have an awful lot of IT equipment sitting in data centers that's effectively running idle but still consuming energy. It's a horribly inefficient way to do things. And we know why we do it. We knew it because so we can burst in terms of increasing workload, demand, et cetera, et cetera, et cetera. But I am sure, and the Commission are equally sure, there's a better way to do it. Rather than having a whole, maybe 50% of the estate sitting there idle, consuming 90% of the power, but doing absolutely nothing, that's just simply highly inefficient. So that's what they're trying to achieve. And what they're asking us to do, and again, I can't give the actual details on it, what they're asking us to do is give the levels of utilization that the IT equipment is actually experiencing over an annual period. That's the intention. How they're measuring it, I'm sorry, dare I say, go and buy the standard and read it, because it's probably beyond my skill set. But that's what they're trying to do. There's also another one, ITEE, which is all about server energy efficiency, which is based on spec power broadly. So that's another one. They haven't requested that yet, but they probably will over time. But I think the interesting thing is that they recognise that it's not the data center that's the problem. It's not the data center itself doesn't consume energy. It's the IT load inside the data center that consumes the energy. So what they're trying to do is bring together the kind of the building piece. Again, rather than just focusing on PUE or WE, they're trying to bring the IT component in and make sure that that is factored in as part of an overall energy efficiency picture. But I hope that gives you enough.
Hi, thank you. Hi. So we're talking about the stick here, right? Regulation. The stick works, but it's not. You cannot only have a stick. And you've talked a little bit about the carrot. Can you talk a little bit more what actually the EU wants to do in terms of carrot?
Good.
Well, the problem is it's got to be divulged down to the member states, isn't it, at the end of the day? It's not the EU that will do that. I mean, I think that taxation, for example, already in the Nordics, there's divergence there. Is if you're reusing your heat, you can get some tax incentive in one country, but you can't in another country. But perhaps you've got more to say about that, Mark.
I'm not sure the Commission really know at the moment. Again, they're on the start of a journey, which is all about data collection. Once they have data, I think they'll start to consider how they can probably incentivize both with the stick and the carrot. I can't give you a solution, but as John suggests, Maybe reduction in taxation, reduction in carbon taxation if you're demonstrating good behavior. Certainly with CSRD, it's access to cheap money. You know, if you're not doing the right thing and reporting it, then you won't get access to sustainable funding, which is cheap money. So that's the carrot on that one. EED, I think, is a little bit more obscure. You know, if they're not very careful, they do what Germany's done. To John's point, you know, Germany's gone sort of overboard and, you know, insisting on 1.3 PUEs and then going down to 1.2, and they're insisting on heat reuse, etc. So the net effect of that was anybody who doesn't need to be in Germany won't be. They'll just drive people out. You know, so the stick has worked really, really well. I'm not sure about the carrot. They need to invent the carrot.
So those data centers are moving to the UK. I mean,
So
any other questions? Yeah. Yeah. This was 3 speakers, so is it 25?
It was 25 minutes, I apologize. Yeah, we don't have any more time for questions, but we want to give an applause to our speakers and anybody that wants to come up and ask more questions after the meeting.